friends, welcome to Math 243, Intro to Probability and Statistics, part the first. Some of you will take Math 244 next term or eventually. I highly recommend it just because it's a nice continuation of the stuff we're going to be doing in here. But what are we going to be doing in here? Well, I like to think of any statistics class as a way to look at the world that's around you and encounter the data that it shows you and be able to, A, see what it's telling you, but also, B, be able to maybe make some conclusions along the way. Take this for example. Just yesterday, riding my bike back from work, I heard this.
New, more contagious variants of the coronavirus are spreading across the U.S., which has many people wondering if there's more that they can do to protect themselves and help stop that spread. One thing some public health experts suggest, double masks. For more on that, we're joined now by NPR health correspondent Maria Godoy. Hey, Maria.
Hi.
All right, so really, I have to layer 2 masks on my face now?
Yeah, that's the idea. These new variants are more transmissible, and that means we need to improve our level of precautions. And one of the easiest ways to do that is to improve our mask by doubling up. That's according to Lindsay Marr. She's a researcher at Virginia Tech who studies how viruses transmit in the air.
A cloth mask might be 50% effective at blocking viruses and aerosols. We're at the point now, though, with so many people who are infected and these more easily transmissible variants, that we need better than 50%.
By double masking, Marr says you can end up with something that's 75% effective or more.
Okay, so if you're like me, you heard that little snippet of that news report, and you thought to yourself, first of all, masks are only 50% effective? What the heck? So first of all, it's cloth masks. They were talking about cloth masks, first of all. Secondly, I think they're basing that 50% on lots of variables. Don't think of the way you put a mask on your face. Think about how often you've been in public and seen people wearing their masks down around their chin, things like that. So put it in perspective. But the other thing that may have caught your attention was, where'd the 75% come from? Like, how do you get 75% from 2 masks each at 50? Wouldn't it make sense that if you put a 50% mask and a 50% mask on top of that, you would be at 100%? Let's take a look, assuming that each mask is no better than a coin flip. Let's take a look at where that 75% comes from. Okay, my friends, let's take a look at this with actual coins. So I've got a penny flipped heads and a penny flipped tails. Now, we've already established that we use coins for this because it's 50% heads and 50% tails. The chance is the same. So let's call heads that the mask works, and let's call tails that the mask doesn't work. Okay, I mean, it doesn't matter which one we use because both of them are equally likely. Okay, so let's look at what happens when you wear 2 masks. So the way I look at it, either both of them work, that's what flipping 2 heads would be like, one works and one doesn't, or vice versa. Now think about this. Why do we have to consider both of these cases? Well, one of the masks is on the inside of your face, and then the second mask is on the top of that mask. So you have an inside mask and an outside mask. In this situation down here, let's say the inside mask works and the outside mask doesn't. And in this situation, it's the other way around. But either way, you've got a mask working, which means that it's going to block the viruses or the aerosols. Here is the only situation where both masks fail and something gets through. Well, take a look at that, my friends. There are 4 total outcomes. If you remember Math 105 with me and the fundamental counting principle, this should make sense. Each of the first pennies can flip 2 ways, and each of the second pennies can flip 2 ways, so 2 times 2 is 4. Yay! But look, there's 4 outcomes, and because they're fair coins, 50% likely, all 4 of those things are equally likely. Now, if you look at it this way, there's only one outcome where aerosols or viruses get through, and it's this one right here. That means only 1 out of the 4 allow something through, which means the other 3 out of the 4 block the viruses. 3 out of 4 sounds like 75%. And that is where I figure they got their 75% from. Now, what's kind of cool about it is we can extend it. Let's put on 3 masks. So here's best case scenario, or I guess a case scenario. All 3 masks work. Heads, heads, heads. It works, it works, it works. Now, you don't actually need the other 2 if one's working, but that doesn't matter because they all work. But then here are the 3 cases
where 2 masks work and 1 mask fails. You could have the inside 2 masks work and the outside mask fail, or some other arrangement of that. Here are all the arrangements where 2 masks fail and 1 mask work. Look at all these outcomes. Of the outcomes we see, every one of these outcomes so far will block the aerosols. You don't have to have all the masks working. You just have to have at least 1 working. As a matter of fact, the only way where it won't work is if they all fail. Now take a look at that. There are 8 possible outcomes, which also makes sense from the fundamental counting principle. 2 times 2 times 2 is 8. In those 8 outcomes, 7 of them block viruses and aerosols. 7 out of 8 gives us about an 87.5% chance of blocking it. That's even better than 75%. What the heck? Let's put 4 masks on.
Okay, let's settle down a little bit. We can't just keep piling masks on our face. Eventually you'll suffocate yourself, which defeats the entire purpose of wearing a mask in the first place. So let's back away from that. I think we got the point. The point is the second mask does make it more effective at blocking aerosols and viruses because it's less likely that the aerosol or virus will get through both. It's called redundancy. It's the same reason human beings have 2 eyes, 2 kidneys, things like that. So you can have one fail and still have the other one work. But I want to back up all the way to the first statement, the first numerical statement that I heard in that 50-second news clip, which was a mask is 50% effective. Only 50% effective. Where did that number come from? Did they just make it up? Of course not. They're scientists. So let's take a look at how we can actually derive a percentage like that from real-world experiments. And it just so happens I did this experiment yesterday before hearing this news report, and it'll still apply today. Let's take a look.